Welcome back to Huawei Routing and Switching Elite Training for HCIE. Today topic we are going to discuss on IPv6. Let's start our part 6.
Now let's look into IPv6 multicast. So here we are going to look into the introduction of MLD, MLD version 1 and MLD version 2. So what exactly is MLD? MLD stands for multicast, listener, discovery. Now previously it's called IGMP. In actual fact, MLD is similar to IGMP in its function, okay, and it's part of ICMP V6 under the header of 58. Alright, so we have two versions, version 1 of MLD and version 2 of MLD. Now version 1 of MLD is similar to IGMP V2, and MLD V2 is similar to IGMP V3 of the IPv4. Okay, now let's look into the Mld V1 Working Principle. Now, as I mentioned, they inherit the working mechanism of IGMP V2. So if you are familiar with IGMP V2, so the MLD version 1 works in similar way. Now let's have a look over here on how they select the query. Now as you can see that the red color here represent R1. Now R1 is going to advertise its general query, so it's actually reach to all the hosts including the R2 router. Now R2 in return also send the query, okay, so we have R1 query and R2 query, so it's also reach all the hosts. Now within this segment I have two routers, which is R1 and R2. Now when R2 also want to become the querier, you can see that the green color represent R2 send a general query. So now I have two routers on the same segment who want to become the querier. So when the router hear two of these query, one of them will become the querier. So in this case, they are going to do a comparison between themselves, and the lower IP address on the IPv6 will win the election. So here we have R1 become the querier. Okay. Now next step here is that you can see we have three hosts, PC1 and PC2 and PC3. Now you'll notice that PC1 want to join to group 2, okay, and PC2 and PC3 want to join for group 1. Now as you can see from here, when I send out the MLD join message, PC2 and PC3 send, but when PC2 send already, PC3 will suppress its MLD join message since one message join is sufficient. Okay, so this join message is sent by PC2 to the querier to join to G1 or group 1, but PC1 want to join a separate group, so it will also send a MLD join message. Now once the message is being sent, those from the higher level router run on PIM, in this case is PIM IPv6 sparse mode, is going to send the multicast to PC1 to PC3. Now assuming that now PC1 want to leave the multicast group, so PC1 is going to send a leave message. Okay, this is a leave message, and the querier in return is going to send a multicast address specific query message. Right, so this is just a very simple mechanism on how the MLD version 1 work. Now next we look into the MLD version 2. Now version 2 is similar to IGMP version 3, where they have the feature of source specific multicast. Okay, so in the MLD version 6, they have a features to include any source or to exclude any source. Okay, so they have a filter function, And they also allow you to track which multicast group that you are going to join. All right, so they have a list of a MLD query and to track who want to join and who want to leave. And MLD version 2 also have a listen, okay, on the status of the receiver. So this is some of the features on the MLD version 2, but primarily because that they have a feature on joining on the specific multicast source. Now let's look into the IPv6 transition. Okay, now even though IPv6 is gaining popularity, but IPv4 is still the dominant as in now. Okay, so we need to look into the transition from IPv4 to IPv6. So this chapter we are going to introduce to IPv6 transition, and what are the technology that's available for the transition include dual stack, IPv6 over IPv4 tunnel, and IPv4 over IPv6 tunnel. Now let's look one by one. Now firstly, we have the technology called dual stack. Now here is very simple, where the router is going to use both IPv4 and IPv6. So maybe I'm using IPv6 on the network, that's my user, and on the public network I'm using the IPv4, so I need dual stack. Next, the common one will be V6 over V4 tunnel. So here I have a router that is running on IPv6, and the network on here is using V4, and the network on the other opposite side is using IPv6. So I need to create a tunnel. So this is called IPv6 over IPv4 tunnel. Okay, so this is the one that we are going to learn. So use as the early stage of transition, which means now. Enable IPv6 packet to be transmitted over IPv4. So assuming that your provider are still in IPv4 and the user already migrated to IPv6. So for us to allow two sites to communicate over the IPv4, we need to set up a tunnel. Now we have two methods for us to create a tunnel. It's either manual tunnel or auto tunnel, automatic tunnel. So for the manual tunnel, all right, we have to do it manually. So either we are going to do a manual tunnel, which is IP tunnel, or we are going to use a GRE tunnel. I'm going to go through it in more detail later. Now definitely this will be more time consuming because it's manual. All right. Another way for us to make this happen is using automatic tunnel. Okay, so automatic tunnel, we have a few methods. It can be IPv4 compatible IPv6 tunnel, or we can use 6 to 4 tunnel, or we also can use ISATEP tunnel. ISATEP stands for Intersite Automatic Tunnel Address Protocol. Again, we are going to look into this technology. Last but not least, we have another one called IPv4 over IPv6. Now this is the other way around, where I have IPv4 on the end user and my service provider is IPv6. Okay, so I have IPv4. So this is most likely where we already majority of us using IPv6 and maybe a small portion still stay in the IPv4. Alright, so that is where the IPv4 over IPv6 will be used later part on our transition. Okay, so it will be maybe many years ahead of us. Okay, and enable IPv4 packet to be transmitted over IPv6. I can imagine that this is purely used for maintaining very legacy or old system in a new IPv6 environment. First in our transition is using dual stack. Okay, as its name suggests, dual means you are running both V4 and V6 on the device. So for this to happen, all devices must support both the IPv4 and IPv6. That is what we call dual stack. Interfaces connected to dual stack network must have both IPv4 and IPv6 configured. Now let's look into this example. Here I have a DNS server, so I have an IPv6 address and the IPv4 address, which is 10.1.1.1 and 3FFE colon whatever IP address colon 1. Here I have a network PC1, I have a router, and I have two separate networks. So on this part I have purely IPv4, and on the other side I have purely IPv6. Now assuming that now I want to connect to my host, and this particular host want to do a query. Let's say now I want to do a DNS query. Let's say I'm going to look for Huawei.com. Now since this is a IPv4 only host, this host is going to query the DNS server using a 10.1.1 that resolving to PC1 address, and this PC1 address again you have both IPv4 and IPv6, and in this case is going to resolve into PC1 IPv4 address, which is 32-bit. Okay, now when you do a query, you are going to query the A record. Now subsequently I have another PC. This PC is just purely IPv6. So again, this PC is pointing to this DNS server. Now when I'm going to ask for Huawei.com, so I expect that I will get a reply for this PC using IPv6. So for this case, this client is going to query the quad A record. Now quad A referring to the IPv6 DNS query. So a query is being made to the DNS server. The DNS server reply you with the IPv6 of PC1, and hence this PC will able to go into the PC1. Now this is where we are going to run dual stack over here. We also have to run dual stack here, and we also have to run dual stack here as well. So this is where all the devices must support the dual stack. Now beside dual stack everywhere, we can build tunnel. Okay, so let's look into the overview of the V6 over V4 tunnel. Now in this topology, on the left here I have pure IPv6, and on the right I have pure IPv6. That is on PC1 and PC2. So you can see that the header is IPv6 on both sides. Now when I transmit my data over the network, I have my service provider that are purely using IPv4. So here it's necessary for us to have a mechanism to allow us to PC1 and PC2 to be able to communicate using IPv6 over the IPv4. And this is how we do it. Now we have multiple ways for us to do that. We can do a manual way or automatic way. So for the manual way, IPv6 over IPv4 manual tunnel, and IPv6 over IPv4 using GRE tunnel. Okay, so there are two ways for us to do that. Now if you look into this diagram, both R1 and R2 is using dual stack, because here that is facing my user, I'm using IPv4, but when I face my service provider, I'm using IPv4. So V6 on the user, V4 on the service provider. So this router R1 and R2 must be dual stack. Now when this data, which in this case PC1 want to go to, destination is PC2. Now when this packet sent to the router 1 is going to look into their routing table. And in the routing table, it will mention that, hey, I have a tunnel. So I'm going to include the IPv4 because the tunnel is IPv4 only. So here I'm going to include the IPv4 header with the destination of the R2 and encapsulate the IPv6 header, which is this 2, the data into IPv4. and transmit over the IPv4 and terminate in R2. R2 will remove the IPv4 and extracted only the IPv6 header. Okay, now this is a very general overview on how the tunnel actually works.
Thanks for watching. Please do not forget to subscribe to our channel.